Hello class and welcome back. Today's lesson will be all about the physical separation of substances. There are two different types of mixtures for each substance, a homogeneous and a heterogeneous. A homogeneous mixture is a mixture where you cannot visually tell the chemicals apart. An example of this would be Coke because you cannot see all the different particles just by looking at it in a glass. A heterogeneous mixture is a mixture that can be seen as different chemicals, so you can pick out all the different elements within the mixture, such as soup, where you could see all the vegetables and the noodles versus the liquid. The first separation method we will be trying is called hand separation. It is quite self-explanatory, but you only use hands or tools to separate big items. It is a heterogeneous mixture, and some tools you could use to separate items would be something like magnets or hands, as I'm doing in this video. So right now I am separating pretzels from sand. As you could see, I'm just using my hand as the tool and taking out each pretzel from the sand mixture. The next method of separation we will be talking about is filtration. Filtration is a method of separation in which you use a filter to separate small particles. Here I am showing my fridge and the water filter inside. The water filter in my fridge separates out small particles such as bacteria to give clean fresh water out through this filter right here. It also does the same process to make nice clean ice cubes into the ice tray in the freezer through the same filtration process. The next separation method we will be using is evaporation. To show this method, I used an orange and its pulp as well as its juice into a pot, and I will be evaporating the liquid from the solid pulp. So as you can see, there is big chunks of pulp inside with the liquid surrounding it. Here is when it started to boil and the juice started to evaporate from the pulp. Evaporation is the process in which you separate a solid from a liquid by evaporating the liquid away. Here you can see that almost all of the liquid juice is almost completely evaporated, but the pulp still remains intact. Here you can see the juice is almost completely evaporated away while the pulp is left behind and can be picked out. The next separation of substances process we have is called distillation. Distillation is using different boiling points to separate different liquids. So here I am pouring a 1/4 cup of milk into a glass of water, and when I evaporate the water at its boiling point, there should be exactly a 1/4 cup of milk left. So here I am pouring the milk and water mixture into the pot, and I am going to boil it and measure it with a thermometer to see its boiling point. So as you can see, it is heading up to water's boiling point, which is 100 degrees Celsius, and the water should start boiling right about now. And of course I dropped the whole thing in the pot. So I grab a new thermometer, and again it is heading up to water's boiling point, 100 degrees Celsius, and as you can see the water is already starting to boil and will be completely gone soon. So here I am showing that the water has been completely boiled out and that only the milk is left. The exact amount, the 1/4 cup that I put in the glass water before, is exactly the amount that's left in the pot. Our next separation method is called solvent extraction number 1. This is a heterogeneous liquid separation method, and it is where you separate two liquids by their density. They will not mix, and if you have a separatory funnel, it will separate the bottom liquid, which of course I did not. So here I am using water and oil to show that water is denser than oil and will stay at the bottom while the oil sits on top. So here you can see the oil stays on top of the water and they are obviously separated and they will not mix. Our next separation method is called solvent extraction number 2. This is a heterogeneous solid extraction, and this is where you separate solids when one will dissolve in a liquid and the other one will not. To show this, I am using salt and sand. If done correctly, the salt will dissolve in the water while the sand will stay present. So here you can see that before mixing, the salt stays at the bottom of the water. There's a little bit of oil in the water still from the last experiment. And now I am adding the sand to the water and salt mixture, and I will mix it around to show that the salt completely dissolves while the sand stays present. Now you can see that the salt is completely gone and that only the sand sits at the bottom of the glass. Our next separation method is called gravity separation. This is similar to solvent extraction number 1, where they are separated by density, except with gravity separation you would use a centrifuge. This is a tool I do not have available, but it does the same thing as the experiment with the solvent extraction number 1. So our last separation method is called chromatography. Chromatography has two phases, a mobile phase, which is the substance and liquid phase, and a stationary phase, which is when different solids will attract at different rates. For this experiment, you will need a wet erase marker and chromatography paper, as well as a glass of water. Unfortunately, I had neither of these, so here I am just trying to show an example of how it would work using a purple Sharpie and a regular piece of paper. So generally with the dry erase marker and the chromatography paper, you will be able to see the different pigments of the dry erase marker raise up the paper at different speeds, and you can see which color raises fastest as it will end up on top. This concludes the lesson. Stay safe and stay healthy, and have